Okay, now let's do this experiment. Let's bring up experiment 10. All right, so this is the same experiment as var ABC as I have shown you, and then let's assemble. Right, and then see the one I showed you in the slide. It exactly follows the similar way. It's basically your your byte start from your 10, right? The next byte 00 is not filled up. Then next byte it's 3210, right? 3210 is my data, right? 3210, yeah, 3210 is my data. So next part is 3210. Now in this data segment picture, what now you need to understand, like each of, let's say, this row, right? This one row start from a base address of 101,000. Then next word location, so next column actually shows you consecutive 4 bytes from higher to lower. The next consecutive 4 bytes from higher to lower. That means for the second column, for example, your lower byte resides in 1001, 0004, and higher byte resides in your 1001, 0008. Okay, so this is 4, 0004, 0005, 0006, 0007. Okay, so 8 means 8 become like that. So your convention, this is kind of word view of the memory, okay, whereas each byte is the lower address of that 4 consecutive byte position. Let's take another example, like maybe value plus 8, what it says. So that means my lower address is starting from 1001, 0008 for this column, which is marked as value plus 8. So your first byte is at 008, next byte is at the next higher byte is 009, then 00A and 00B. Okay, so our now our variable A, that label, contain a byte which is at 1001, 0000. The next byte space, like 001 is blank, nothing written there. We'll talk about that later in the next lecture. And then it is 1001, 0002 is 10, and 003 is 32. So what type of endianness it is following really? So it is following your lower byte goes to, I think it is 3210, right? So lower byte goes to the lower address, higher byte goes into the higher address, right? Isn't it? So it is a little endian convention. Lower address, lower element or little element goes to the lower address is a little endian convention. Similarly, my whole word, which is like 76543210, that comes as starting from the lower part is a, see, this is the higher, this is the lower, right? It's laid down in the same way, 76543210, and that way your 004 location has 10, 5 has 32, 6 has 54, 7 has 76. Lower address contain the lower byte is a little endian. Now one more thing, now in this context I want to show you is remember we were defining some string in maybe not experiment 1, maybe experiment 3. Let's look at that. Yeah, ASCII, right? If we assemble it and go to the ASCII, right? It's kind of a counterintuitive order, right? THE space, then ANSW, right? So it is kind of that way we couldn't understand that at that point of time when we did an AXP3. Now, with the memory layout, now we should have a better understanding. What is happening here? This string is laid down. Remember, its equivalent is a dot byte. DOS ASCII Z is nothing but dot byte with the ASCII code of each character. And when assemblers start laying them down, it always starts as a lower address. That means T goes to the lower address. Next higher address goes H. Next higher address goes E. Next higher address is a space. Each of the characters is 1 byte, right? So that's why your T goes to the lower, then H, then E, then space, and then next higher starts at this right hand side, A, N, S, W, E, R. So it's having this weird way of showing it on this graphical interface. But it's on reality, this whole string is laid down from the lower memory to the higher memory as a single byte for each character. So that's all for this lecture. If you have any question, please ask me in class or send me email.